Hello, hello. All right, real short video today, guys. It is the last official lecture video. Okay, lecture video 7 is the last one of this unit. All right, because for those that have lab tomorrow, which is my period 1 and 7, guys, you've got lab tomorrow, and then class, which will be associated with this material. Class is going to be on Wednesday for you guys to finish up the chapter. My guys that have from periods 4 and 9, you guys will have lab on Wednesday, which means all this material here will be for you guys tomorrow on Tuesday. All right, we'll have a review day on Thursday, and then Friday, like I mentioned in class today, is going to be our chapter quiz. Again, this is going to be a quiz, a 40-point quiz, so don't freak out. I know this has been a relatively large chapter, but I'm only keeping this a relatively short quiz, 40 points in the quiz category only. Okay. All right, let's get on to it. 3 more things to talk about today, and it's kind of just 3 more equations we're going to throw at you that have to do with some of the things that we've been talking about. We've been talking about colligative properties the last couple of class days. Now, today is going to be dedicated to both boiling point elevation and freezing point depression, as well as a third equation on osmotic pressure, right? And these are all the 3 different colligative properties that I've mentioned to you guys. There was the vapor pressure lowering one that I mentioned, in the video as well as in class. But again, that one's not going to be nearly as important as these 3. So let's get into them. And of course, we're going to do some practice problems with them in your class period designated to this video. But let's take a look at this first one here on boiling point elevation. So both boiling point elevation and freezing point depression are going to look relatively the same, and I'll give you a quick sneak peek. This one right here is freezing point depression, so they look almost exactly the same, okay? But back to boiling point elevation. So each of these pieces are as follows. T is change in boiling point. So this guy right here, this delta T lowercase b is associated to change in boiling point, okay? So again, just like when we see this delta symbol right here, right, this triangle right here, this is assuming that we've got a T final minus T initial type thing, right? So that's what delta T is equal to, okay? So we've got 2 different measurements of temperature required in this delta T right here. Okay, so temperature final minus temperature initial is what delta T B is equal to. Okay, so we got 2 measurements of temperature final and initial. So don't forget about that when we're going to utilize this formula. Okay, next up is I, which is the number of ions in solution. And guys, this comes directly from your dissociation reactions. Okay, so for example, if we do a reaction like, I don't know, let's say NaCl, real basic, right, turning into Na plus and Cl minus, okay? Well, you have an invisible coefficient of 1 and an invisible coefficient of 2 in front of this, so that means your I is going to equal, your I is going to equal 2 in this particular case. Okay, that's a really crappy 2. Let's try this again. 2, okay, because you've got 1 ion right here and a second ion right here. Now, let's say you've got a different scenario here where you've got MgCl2, okay? Well, now this is going to break apart into different ions here. Okay, let's change that arrow. Okay, so the Mg ion is going to be Mg, of course, plus 2 that we're all very familiar with, but it's going to also break apart into a Cl minus ion. But as we know, when we take a look back at the actual compound itself on the left-hand side here, we have an invisible subscript of 1 here for magnesium, and of course a subscript of 2 right here for chlorine. So that means we have technically a coefficient that's invisible of 1 for magnesium and an actual coefficient of 2 in front of Cl. So that means, that means we've got 1 magnesium ion and 2 Cl ions. So that means in this case here, I is going to equal 3. Okay, so make sure you take that into account whenever it comes to calculating boiling point elevation as well as freezing point depression, because both of these have this I variable in it, right, which is the number of ions in solution. Now, next up is Kb. Kb is referring to a constant, right? It's your constant for, it's your constant for boiling point elevation. Okay, it is a positive 0.52 degrees Celsius divided by molality. Okay, so again, lowercase m is molality. So the unit for this constant here is degrees Celsius per molality. Okay, degrees Celsius per molality. And again, it's a positive 0.52 degrees Celsius divided by molality. And then lastly, we've got molality itself, lowercase m. So this is not going to be mass here, okay? So this right here is not mass, okay? Not mass. So we have to make sure we recognize that when we utilize this formula, okay? So again, we've got change in temperature, change in boiling point, ions, number of ions in solution, Kb constant, which is positive 0.52 degrees Celsius divided by molality, and then finally lowercase m, which is just molality of solution. One final thing to mention, okay, if we take a look specifically at our unit for the Kb, notice the measurement of temperature being utilized in this constant. It's degrees Celsius, which means whenever we look at any kind of boiling point right here for delta TB, we have to make sure that all of our measurements for temperature are, of course, in degree Celsius, okay? We do not want Kelvin, okay? So no Kelvin this time around, okay? Now we're used to utilizing Kelvin, especially from chapters 11 and 12 with all our gas law stuff, right? But in this particular case, guys, we want to use degrees Celsius, okay? We do not want to use Kelvin. So no Kelvin here, just degree Celsius. Otherwise, it's going to throw off your calculations, and it's not going to be correct. Okay, so that's change in boiling point there, boiling point elevation. Now, again, we had a little sneak peek of this delta F, or delta TF equation, right, for freezing point depression. It's basically the exact same thing, okay? We once again have delta T, this time lowercase f, okay, which is going to be your change in freezing point. So once again, we're utilizing a T final minus T initial approach with this delta TF here, okay? We once again have our I here, right? I is once again here, number of ions in solution. It's the same deal, right? It's going to come directly from your dissociation equation. So depending on however many ions you get from your substance being referred to, that's going to be your I here, okay? Now, next up here is your Kf, right? Different constant here. K lowercase f here is going to be a different number. Now we've got a negative 1.86 degrees Celsius divided by molality, okay? Degrees Celsius by molality, per molality. So a slightly different number here, okay? So if we go back to boiling point elevation, again, positive 0.52. This time with freezing point depression, we've got a negative 1.86, okay? So it's a little bit different in terms of what you should be plugging into this equation. So if you're talking freezing point depression, you need to use Kf here, which is negative 1.86 degrees Celsius by molality, okay? And then lastly, of course, once again, lowercase m is molality itself, okay? So again, these two equations, boiling point elevation and then freezing point depression, pretty much the exact same. Last here is osmotic pressure, and again, we're plugging in all of these wonderful different variables into this equation here, and it's basically, you know, just another equation, okay? You will be given all of these equations here, these last three I just showed you, on a separate sheet of paper for the quiz this Friday, so don't lose it, okay? It's all good. You don't have to memorize these equations. I'm not that crazy, okay? But here's your osmotic pressure, and again, we're going to be doing a bunch of examples of these in class on your next upcoming class day, okay? Have a good day, guys. See ya.